Hello everyone, let's talk about another medium problem on Leetcode today. Find valid matrix given row and column sums. Leetcode 1605. In this problem, we are given two arrays, row sum and column sum, of non-negative integers, where row sum I is the sum of the elements in the ith row, and column sum j is the sum of elements of the jth column of a 2D matrix. In other words, we do not know the elements of a matrix, but we do know the sums of each row and column. Then we have to find any matrix of non-negative integers of size row sum into column sum that satisfies row sum and column sum requirements. So we have to return a 2D array representing any matrix that fulfills this requirement. It is guaranteed that at least one matrix that fulfills a requirement exists. So then they have given some examples as well. So in example 1, we can see that row sum is 3 and 8 and column sums as 4 and 7. So one of the metrics that is given to us is like 3, 0, 1, 7. So if we sum of the rows, like the first row and second row, we get 3 and 8. And if we sum of the columns, we get 4 and 7. Now let's look at another example. Then we get 5, 7, 10 as row sum. And then as column sum, we get 8, 6, 8. So again, one of the metrics given to us is 0, 5, 0, 6, 1, 0, and 2, 0, 8. So then again, we see that the row sums and column sums match, like 5, 7, 10 are the row sums, which are actually adding up to the rows given to us, and column sums, that is 8, 6, 8 are actually matching as well. Now let's see how we can actually solve this problem. So one of the requirements is that this matrix should only contain non-negative integers. So that means 0 is allowed and positive integers as well. So suppose we were only given the row sum for now. Let's take example 2. So 5, 7 and 10 are the three elements that are given to us as row sum. And suppose we have to make a 3 into 3 matrix, right? So then how will we be making it? So there are multiple ways of making it, right? One of the easiest way can be that let's assign 5 to this one and then assign rest of the rows as 0. Then similarly, let's give 7 to the first element in the row, then give 0 to rest of them. And then similarly for last row, assign 10 as the first element and then add 0 as the remaining elements. So this becomes very easy when only one row or column sum is given, right? And because of additive identity property of 0, that is when we add 0 to the number, it doesn't changes. We still get like a non-negative number, which is a requirement in this problem. So 0 actually helps us achieve this. But when we add actually another dimension to it, like now suppose in this case we added row sum, but now we also take column sum. Like we take 8, 6 and 8. Then we have to modify our approach because we have to also take care of the column sums. And also note that there is a constraint that sum of row sums is equal to sum of column sums. So we can see that sum of row sum is in this case 22 and column sum is also 22. But when we actually look at our rows right now, for example, row 0 adds up to 5, but 0th column sum is not 8. So how we can actually fix this problem? So one of the easiest way can be that, okay, we can keep this one as 5, but now these two elements have to be somehow reduced to 3, right? And now because they are already 17, how can we bring it down to 3? So one way can be that, okay, I make this element 3 and then make this one 0. But now this element has to be 4, right? Because there is a sum remaining of 4 here, right? But now again, there will be a constraint coming in from the second column. So how do we actually solve this problem? And this is where the greedy approach comes into picture. So what do we mean by greedy approach here? By definition, greedy approach is based on the principle that locally optimal choices lead to the globally optimal solution. So we make decision on each cell level and hope they work on the overall matrix level. So what we can do is, like, for each cell, we actually take the minimum value between the row sum I and column sum j, such that we ensure that we never exceed either of the sum when we are actually iterating to fill up this matrix. And why this solution will work? Because the problem guarantees that there exists at least one matrix that fulfills requirement criteria. And second thing is, when we are choosing the minimum and updating the row sum and column sum, we are guaranteed that we will never exceed either of the sums. So now let's see how we can actually make it work. Now let's take example 2 again. We can see that column sum is 8, 6, 8 and row sum is 5, 7, 10. So we start iterating row wise and then column wise. We are at I equal to 0 and j equal to 0. So what is the minimum between column sum 0 and row sum 0? It is 5. So we will take 5 as a value here and reduce row sum and column sum So row sum now becomes 0 and column sum is also reduced by 5. So now it becomes 3. So now we are at row 0, column 1, and we can see that the minimum between row sum 0 and column sum 1 is 0. So we will take 0. And then we go to the next value in the row. The minimum is again 0 between 8 and 0. So we will pick up 0 again. So now we go to the next row. And we can see that the minimum between column sum 0 and row sum 1 is 3. So we will pick 3 and then reduce the value of column sum 0 and row sum 1 by 3. So now we can see that row sum 1 is 4 and column sum 0 has become 0. Now we come to I equal to 1 and j equal to 1. And we can see that the minimum between row sum 1 and column sum 1 is 4. So we take 4 and now row sum 1 becomes 0 and column sum 1 becomes 2. Now we will go to the cell with row equal to 1 and column equal to 2. So again the minimum is 0. So we will take minimum and move to the next row. Now we come to the last row, I equal to 2 and j equal to 0. We can see that the minimum value is 0. So we will pick that. Now we can see that for row 2, column 1, we can see that the minimum value is 2. So we will pick it and reduce the values in both column sum and row sum. So now we get 8. So we can pick either of them now. And for example, we pick up from the row sum. So we got 8 here and we reduce the values again. So this is how our matrix will look. Now that we have seen this, let's jump into the code part. First thing we do is we define the dimensions of the matrix. It will be size of row sum into size of column sum, because the row sums tell us how many rows we have and column sum tell us how many columns we have, right? Then we will just initiate this matrix and then we will run the nested loop row wise and column wise. Now we will just pick up the minimum value between row sum I and column sum j. So now we will just set this value in the matrix and reduce the respective sums. So it should be row sum I and similarly column sum j. And finally, hopefully we will have our matrix and we will just return it. Now let's run this code. It should be new int, not new matrix. Sorry for the typo. Let's run it again. And now what's the issue? Because I'm defining single dimensional matrix here and initiating multi-dimensional matrix. Now it should hopefully fix it. Now let's submit this code. Cool. In terms of time complexity, it is O of m into n, where m is number of rows and n is number of columns, because we are running a nested loop, first row wise and then column wise. And in terms of space complexity, like we are not using any extra space, we have to return this matrix. So in a way, auxiliary space complexity is O of 1. But if we look at the space complexity of this problem, it is O of m into n, because we are creating that matrix and then returning it. I hope this video was useful to you. If it was, please like and subscribe. Have a nice time. Thank you.